Hi, you guys. I wanted to go through and give you a quick intro to your 7-1 notes to try to help answer some questions before you get started so you can sort of attempt to teach yourself. Part of the reason why I'm okay with doing it this way is, well, I'm not there, and because you have seen exponential growth and decay functions from Algebra 1, so it is a little bit of review. So if you don't already have the 7-1 notes from the sub, pause this, ask for the notes. The first instructions that I had in my plans were for you guys to get those. So make sure that that happens and we will get started. So an exponential function is of the form y equals a times b to the x power. So you'll notice I put b in parentheses. That does not have to be in parentheses. However, sometimes it's helpful to see it that way, so that way you know that b is the base and x, or what x is being raised to. So x is not the exponent of a, it's the exponent of b. So that's why I put the quantity around there. So it's important to recognize the base, just like we had seen with rational exponents and things in the last unit. For all exponential functions in that form, a is actually the y-intercept. So moving forward the next few days, whenever we start talking about transformations, it'll be super important and just very nice and convenient to have that a value there, because that's kind of a starting point for us. So we'll be able to see if there are any transformations going on based on that ordered pair for the y-intercept. So if you take a look down, I've compared exponential growth and exponential decay. So we're going to start on the left side with growth, and then we'll go to decay, and I'll show you one graph and then kind of show you, obviously, on the key that I attached on Schoology, where you can kind of go through and work through this stuff with a partner. So for exponential growth, if we look at A, we call that the initial amount, also known as the y-intercept. So it's just where it starts. And then the B value is going to be 1 plus R. So R is the rate at which it's increasing, and it's always written as a decimal. So if I give you a 16% increase, then that would be written as 0.16. So I'll show you on this key that I attached. It's a little bit more detailed. So I'm going to ask you guys to, once I've gone through this video, I'm going to have you guys come back to the key and go through and see if there's anything that you can add to your notes to make them either make more sense or just have a little bit of extra reference for you whenever you're working on homework. So if you look here at this B value where it says 1 plus R, I have a little arrow here and I said the growth rate R is a percent written as a decimal. So that's just another place where you can kind of get some supplemental information. So I'm going to flip back to my slide, but I just wanted you to know that this key, which I'll reference again shortly, is also on Schoology. So it'll give you an opportunity to kind of see some details that I'm not able to kind of type in on my slides. So back to the 1 plus R. Again, R is the rate, and exponential growth is modeled when the B value is greater than 1. So obviously if B is equal to 1 plus anything, then it's going to be greater than 1. So if you have 1.01, that is still modeling exponential growth. If you have 1.9, also still modeling growth because B is greater than 1. So that's kind of the key thing. We need to make sure that B is always greater than 1. Some key words to look for so you can recognize that you have an exponential growth function are words like grow, hence the name, exponential growth, increase, appreciate, and so on. So you'll be looking for a key word, and I'll give you an example of this to kind of give you a hint as to whether you're looking at exponential growth or exponential decay. Okay, so again, overall, we said that the exponential function is always of the form a times b to the x power, and it's just super important that you recognize that exponential growth, that b value is always going to be greater than 1 and 1 plus the rate, again as a decimal. So if we take that exponential growth and then kind of compare it to exponential decay, you'll notice the a values are the exact same. So they're both initial amounts, also known as the y-intercept, also written as an ordered pair 0a, like I have written up above. Okay, so that's common between exponential growth and decay. You'll notice that the b value of exponential decay is different. So it is 1 minus r. So decay meaning it's decreasing. So it kind of makes sense where exponential growth is greater than 1, it's 1 plus r, the decay is going to be 1 minus r. R is still the same percent that you're looking for within the problem, and it's still written as a decimal. So there are a lot of similarities, so you just have to recognize that decay is 1 minus r for that b value. And exponential decay is modeled when your b value is in between 0 and 1. So you'll never have a b value that's negative, but if it's in between 0 and 1, you know that it's modeling decay. And then I just have some keywords. So decrease and depreciate are some words that you'll see that kind of will give you a tip that you're looking at exponential decay. So again, what I have in red here, you guys, is super, super, super basic and very simple. So once I'm finished with this video, I'm going to encourage you to work with a partner and look through the key on Schoology to be able to add and supplement to these very bare basic notes that I've given you. And of course, tomorrow, whenever I'm back, I will go through everything and make sure that we're all on the same page and feel good about this. So if you look underneath, I have two graphs. So example 1 is f of x is equal to 2 to the x power. So hopefully we recognize, because there's that 2 there, and because of what we just set up here, oh man, it all went away. When exponential growth is modeled, b is greater than 1. And so this gives us an example of exponential growth versus example 2, where we have 1/2 to the x power, because 1/2 is in between 0 and 1. That's modeling decay. So when we look at example 1, I created just a quick table right here for you guys. So if you want to sketch that in between the two graphs, you can, and then you will have some space. You guys have space on the margin on the right side of example 2 to be able to create another quick breakdown, or quick table, excuse me, for your ordered pairs for example 2, which I'm just going to have you guys do on your own. Per usual, we are using the same key points that we've used all school year. So -2, -1, 0, 1, and 2 for x. So again, anytime you're graphing, you're basically using those key points. And then we're going to check out our y coordinates. So basically we're saying, okay, 2 to the -2nd power. If you look at that and you say, oh, that's totally simple, that's -4. Yeah, that's wrong. So you need to make sure that you're paying close attention to what you're calculating. And if you don't know, use your calculator. Because 2 to the -2nd power actually equals 1/4. So 1/4 would then be your y coordinate. So you'd have the ordered pair 2, -2, 1/4. Okay, so if we continue and do the exact same thing, so we have 2 to the -1st power, so that's going to be 1/2. Then we would have 2 to the 0 power. Anything raised to the 0 power always equals 1, 100 out of 100 times. So that one is very simple. And then we have 2 to the 1st power. So that is equal to 2. Whoops, excuse me, it's 2. And then 2 squared obviously is 4. So if we go through and just do some quick ordered pairs here. So when x equals -2, I'm going to make a crazy pen. Hopefully it works. There we go. So when x is equal to -2, y is equal to 1/4. So I'm going to come over here to -2. 1/4 is going to go about here. When x is -1, y is equal to 1/2. That's about here. When x is 0, y is 1. That's there. When x is 1, y is 2. And when x is 2, y is 4. Okay, so there are my 5 key points for that particular function. So I'm going to see how I can do with this pen. So connect those. Your function is going to look something like that. I'm using a trackpad mouse, so mine is not great. But what I do want you to notice, first of all, is that this function is increasing. Okay, so it's modeling exponential growth. So it's always increasing as your x coordinates are getting x values are getting larger, so is y. And then you'll notice down here, so this function actually keeps going on and on and on and on and on and on and on. I want you to take into account for both example 1 and 2, I put these on here, but I have these pink lines, dashed lines there. That's called an asymptote. So an asymptote is basically this, I don't know, it's a line, and the function can never cross it. So it's like this huge barrier. So this function, while it looks like it's getting close to 0 and might approach 0, it only approaches it. It never touches the x-axis. So I'm going to be kind of picky with your graphs. I need you to be neat. And just make sure that when you're creating your function, it does not ever cross the x-axis. Okay, so again, those are called asymptotes, and I'll talk more in detail with you guys about those. But again, I'm going to kind of take you back to the key, which is attached to this portion of Schoology. And every single exponential function that we're looking at, whether it's modeled by exponential growth or decay, has this what we call the horizontal asymptote at y equals 0. So that's going to be something that we're going to look at in detail the rest of the week, especially when we talk about transformations. So in terms of transformations, if you look down here at this question that says, how could the range be changed by a transformation? Basically, what we're going to talk more about is that the range is going to be determined by this asymptote. So for both example 1 and example 2 that you'll see here, the range goes from 0. Ooh, that should not be a bracket. That should definitely be a parenthesis. Make sure on your notes this is a parenthesis. That is my mistake. Both range values here and here in example 2 should have parentheses for the range. Because 0, it's just approaching 0. It doesn't actually touch that. And then hopefully the domain is obvious that it's going to be from negative infinity to positive infinity for both of them. So again, make sure that you're using this kind of as to supplement the notes. I'm going to go back to my slides really quick and talk about one last thing, just to show you some keywords, and then I'm going to let you guys be and let you do your own thing. So I'm going to highlight just keywords for you. So if you look at example 4 and 5, so you'll have to flip your page over. Example 4, you can read all the specifics, but it says that this weight is increasing at a rate of 16% each year. So that's super important to recognize that it's increasing because that's going to be exponential growth. So you're going to be considering 1 plus R, which is your rate. And if this rate is 16%, then your R value is going to be 0.16. So your B value is going to be 1.16. Okay, so again, I have that in detail on the key that you'll see. And then I want to draw your attention to example 5, same exact thing. So it's saying you're buying this motorcycle and it's going to be worth 6% less each year. So because it's less, it's exponential decay. So your B value is going to be 1 minus R. In your case, that's going to be 1 minus 0.06, which is equal to 0.94. So just a quick, I just want to point out that highlight the keywords there. So make sure that you're looking for those so that you can determine what your B value is going to be, and be super careful with your R as a percent written as a decimal. So I'm going to encourage you guys, not encourage you, I'm done here. But I want to make sure that you guys find a partner or a small group of 3 if you'd like. And I want you to kind of work through these notes. So I prefer that you go through and try to do them on your own and then use the key as a reference as needed. So kind of go through those given the quick intro that I gave you, and then again, use this as a supplement. And if you have no clue how to do something, then make sure that your group is opening up this key and you can go through and kind of work through some things, check out my notes, and see if you can make sense of things. Maybe your group can join another group if that makes sense, if it makes sense to other people, and you can kind of try to get an explanation with that. And of course, tomorrow I'll make sure that I come back and kind of fill in any gaps that you guys have. So please make sure that you check your Schoology notes so that you know the proper homework assignment, and have a great day.